Hello guys, welcome back to the university. In this video, we're going to teach you how to solve the electrostatic force that exists between charges. So let's go and let's have a sample problem. And we are going to solve this sample problem completely. The sample problem tells us to calculate the electrical force that exists between two protons, which are placed 1.5 times 10 to the negative 9 meters apart. We are also given a data right here about the electric constant K, and it has a value of 8.99 times 10 to the 9 Newton times meter squared all over coulombs squared. Alright, so let's have step 1. So what will be our step 1? So I think it is much easier for you guys if you were able to have a picture of the problem inside your mind. Alright, so you need to draw the situation, because if you can do that, I think you can attack the problem with ease. So I'm using this diagram that shows us two protons which are separated by a certain distance apart, and you will see that the lines of force are diverging. This means that they tend to push one another apart, and you will see that we have a repulsive force that exists in between them. Alright, so I hope that you were able to grasp the illustration and what is being asked by the problem. So it is asking you if you can find the force, the amount of the repulsive force. Alright, so step 2 is know your data. Okay, some data are not included in your problem or not stated, but your teacher knows that you have prior knowledge about the subject matter, and you can use those prior knowledge in order to get all the data that you need in order to solve the problem. In our case, I have already included it. So we have the value for the charge of the proton, which is 1.6 times 10 to the negative 19 coulombs, and we also have the distance of separation, which is 1.5 times 10 to the negative 9 meters. And we also have the value for K, which is 8.99 times 10 to the positive 9 Newton times meter squared per coulomb squared. So that's our step 2. Next is step 3. So for step 3, identify the equation or equations that you have to use. Basically, it can be one or two or more equations. It depends on the number of variables that you are looking. Okay, so for our problem, this is the formula for the electric force or the electrostatic force. So Fe is equivalent to K, okay, which is the electric constant multiplied by the value of the magnitude of the first charge times the value of the magnitude of the second charge divided by the distance, or the square of the distance of their separation. So you now have the formula. I think by the data we can already substitute, but wait, so there's more. So you can actually do step 4 first, and you can also check if there is a hidden problem. Sometimes students jump readily to the substitution of the data to the variables or to the equation, but they did not check if there are hidden problems, so the resulting answer is wrong. Alright, so because it is better if we check. So if there is no hidden question in the problem, you can now substitute your values to the equation. Okay, so step 5, we have step 5. Alright, so step 5 is to substitute the values. So to this equation, so F sub E, okay, is equivalent to K times Q sub 1 times Q sub 2 all over R squared. And upon substituting, you will see that the values are, your equation will look like this. Alright, so you have 8.99 times 10 to the 9. Alright, so this thing right here is actually the units. So I put the units because later on we're going to do the dimensional analysis to show that the units are correct. So it's upon plugging in, and you can actually press it in your calculator, you'll find out that it is 102.28 times 10 to the negative 12 coulombs or newtons. Okay, so it does not have any unit right here, but the unit here is newtons, and here we're gonna show why it's newtons. So step 6 is to affix the correct unit, or we are gonna use the dimensional analysis. Alright, so from this equation, so we have the unit for K right here, so that's Newton times meter squared, okay, divided by coulomb squared. So the unit of charge is C, or coulomb, so C times C is C squared, and the value for, or the unit for the distance is M, and then you have to raise it to the power of 2. Okay, so you will see that all right, okay, I'm gonna use my pen right here, that this will cancel out. Okay, yep, so because this one is just C squared and it's in the numerator, so this thing will cancel out, and also this one, because M times M is M squared, and it will cancel out. So the unit for that is Newton, so you're gonna use N for newtons. Okay, so I hope you guys learn how to properly solve the electrostatic force that exists between charges.